Hi there. So in this section, we're going to take a deeper dive into polynomial functions and really focus on how do we compute the zeros of a polynomial function. We'll be looking at real as well as complex zeros. There will be we'll be using long division and synthetic division at various points. So I thought here at the top we'd revisit old school long division where we just had 685 divided by 3. Going to go through that process before we step it up a notch just below here in the bottom two examples where we look at dividing a polynomial by a factor. So with that said, if we do old school long division, remember how you put your divisor out here and you ask yourself, well, 3 times what gives you 6? And that would be 2. You take that number and multiply it times the piece outside, so 2 times 3 is 6. Draw your line, change your signs, and then 6 minus 6, of course, is 0. You bring down the next term. 3 goes into 8, also 2 times. 2 times 3 is 6. Draw your line, change your signs. 8 take away 6 is 2. Bring down the 5. 3 goes into 25. What's that, 8 times? 8 times 3 is 24. Draw your line, change your signs, subtract, you get 1 left. This 1 down here is referred to as your remainder. A little bit of vocabulary terms here. The 1 is your remainder. The 3 out here was your divisor. The 685 is the dividend. And the answer that you found is referred to as the quotient. That's what I always say whenever you're dividing something. They say find the quotient. And that means just the answer, essentially. Okay. We'll be using those exact same techniques where I was drawing the line, change my signs, as we work through long division of polynomials, taking a polynomial and dividing it by a factor. When you do long division of polynomials, you'll notice here how in example 1a, the polynomial is already in descending order, but notice how it doesn't go down in descending order numerically. It jumps from x to the 4th to x squared. So when you set up your long division, your dividend in here, you want to be sure that you put placeholders for any degrees that you're missing. So I have x to the 4th. I don't have any x cubed, so I put 0x cubed. Then I put my minus 26x squared. I'm missing an x term, so I put in 0x plus 25. So now I ask myself, x times what gives me x to the 4th? X times what gives you x to the 4th? That would be x cubed. Now I take this x cubed and I multiply it times both terms on the outside. So x cubed times x, be x to the 4th. X cubed times negative 5, negative 5x cubed. Draw your line, change your signs. Let me use a different color to emphasize that. This will turn into a minus and a plus. That first term cancels out now. And now I'm left with 5x cubed. Bring down the next term, minus 26x squared. Now I ask myself, x, this x is sitting out here in the front, x times what gives me 5x cubed? So essentially there's a 1 in front of this x, so 1 times what gives you 5? So that would have to be a 5. And then you've got 1x, but you need 3, so you're going to have x squared up here. So now 5x squared times x, 5x cubed. 5x squared times negative 5 would be a negative 25x squared. Draw your line, change your sign. So the 5x cubed becomes negative, the 25 becomes positive. The x cubed terms cancel out. If that first term doesn't cancel out on you, you've done something wrong. Okay. Negative 26 plus 25 will give me a negative 1x squared. Bring down my next term, plus 0x. 1 times what gives you negative 1? That'd be negative 1. I've got 1x, but I need 2, so I'm going to have a negative 1x. Now I'll take this negative 1x and multiply it times x. That would give me negative 1x squared. Negative 1x times negative 5, positive 5x. Draw your line, change your sign. So positive, negative. The 1x squareds cancel out. Now I have negative 5x. Bring down the 25. So plus 25. 1 times what gives you negative 5? So that would be negative 5. I have an x, and that's what I needed, so I just have negative 5. Negative 5 times x, negative 5x. Negative 5 times negative 5, positive 25. Draw your line, change your signs. Positive, negative. Cancels out. 0 remainder in this case. Okay, so now since I have 0 remainder, what that means, as we move forward, since your remainder is equal to 0, then we can determine that this triangle up here just means therefore in mathematics, so a triangle of 3 dots there, that means therefore x minus 5 is a factor of the polynomial. That full polynomial here, the x to the fourth minus 28, 6x squared plus 25. That's going to play a role as we move forward in this section, okay? But it only is the case because your remainder was equal to 0, okay? All right, let's scoot on over and let's look at another one together. If you feel good about it, I'd pause the video and try it solo, okay? The one over here on the right, if you notice your polynomial here is already, it's x cubed, x squared, x, then number, so it's already in descending order, and I didn't need to put in a placeholder. I'm dividing by x minus 2, the imaginary 1 in front of this x. So I ask myself, 1 times what gives me 4? So that would be 4. I've got 1x, but I need 3, so I'm going to put x squared. So now I take this 4x squared and multiply it times both terms. 4x squared times x, 4x cubed. 4x squared times negative 2, a negative 8x squared. Draw your line, change your signs. That way your 4x cubes cancel out. 8 minus 3 will give me a positive 5x squared. Bring down my next term, so I have plus x. 1 times what gives you 5? Be a positive 5. I've got 1x, but I need 2, so I put another x up here. 5x times x, 5x squared. 5x times negative 2, negative 10x. Draw your line, change your signs. That's usually the most common thing folks forget, is to change their signs. Draw your line, change your signs. The 5x squareds now cancel out. 11x, bring down that last term, plus 7. 1 times what gives you 11? Be positive 11. You have an x, you needed an x, so you don't need to put anything else with that 11. So 11 times x, 11x. 11 times negative 2, negative 22. Draw your line, change your sign. X's cancel out. 7 minus 22 will give you, oh, I forgot to change both my signs. I just saw, I was like, there's something wrong here. Okay, so sorry. 11 times negative 2 was negative 22, and I didn't change both my signs. I see I just did exactly what I said most common mistake was. Add both of these together, we get 29. You're getting a remainder here. So what that means then is that since you've got a remainder, therefore we can say here that x minus 2 is not a factor of your polynomial. That original polynomial here, this 4x cubed and so on, okay? But it does tell us that there's a point on the graph, but we'll talk more about that later, okay? But at this point, because you get a remainder, then this, what we were dividing by here, is not a factor, okay? Another way to do division of polynomials whenever you are just dividing by x plus or minus a number is that you can use what is referred to as synthetic division. Again, it only works if it's a single x added or subtracted a number, okay? If you have something in front of your x, you won't be able to use synthetic division, and you have to use long division. That's why I needed to show you both, okay? Again, these are techniques that you'll take with you for those of you going on to calculus. When using synthetic division, you're going to divide by the 0 that would come from the divisor, okay? So what that means then, here in example 2, if your divisor is x plus 11, here's your divisor, it's x plus 11, then the 0 would be, okay, well then you're setting that equal to 0 and you're solving for x. So the 0 would be negative 11. You would be using negative 11 in synthetic division. So you always use the opposite of whatever the factor is, you're using the opposite. So here, if the divisor is x minus 2, then the 0 would be positive 2. Okay, you use the 0 in your synthetic division. Below here are the steps for synthetic division. I'm not gonna, they're here, okay? I'm gonna illustrate them rather than talk you through it. Let's do it in real time. All right, so let's do example 4 here together. So here I've got a polynomial, and I'm dividing by x plus 3. Same rules apply here, that if you are missing a if you're missing a term, you're going to put in a 0 as a placeholder. Here I'm dividing by x plus 3, so what goes out here, you're going to create a little box, and you put the opposite of this positive 3, so we'll put negative 3 out here in my box. I line up the coefficients that I have here of my polynomial. Notice how it's x cubed, x squared, and then it jumps to numbers. So I'm going to have the 2 for the x cubed, then I have my x squared. I'm missing the x term, so I put in a 0, and then I put in my negative 5. Skip a line on your paper, and then just draw yourself a blank line. Above this line, you will be adding or subtracting. Below the line, you multiply. Okay. The first term always gets brought down below the line. And if it's below the line, then you take the number that's out here in your little box and you multiply. So negative 3 times 2 gives you negative 6. So you're gonna kind of oscillate between above and below this line. So you always bring down the first term. Now negative 3 times 2 gives you negative 6. Now you're above the line, you just add these together. So 7 minus 6 gives me positive 1. Below the line, negative 3 times 1, negative 3. Now you're above, so you're adding. That gives me negative 3. Last piece, negative 3 times negative 3 gives me positive 9. I'm going to draw another box here. 9 minus 5 gives us 4. What this now tells us is that if you took this polynomial here and divided it by x plus 3, then you will get a reduced polynomial, and these are the coefficients. So if you started here with x cubed, these are now the coefficients of a polynomial of 1 degree less. So this is x squared, x, and number. And out here in the box is your remainder. So what we have just found here is that this is now 2x squared plus x minus 3. If you take this 2x cubed plus 7x squared minus 5 and divide it by x plus 3, you're going to get this expression, 2x squared plus x minus 3, with a remainder of 4. Okay. These numbers 2, 1, 3 are the coefficients of your reduced polynomial 1 degree less. Okay. Let's do another one together. Out here in the box, we put in a positive 1. It's the opposite of what you see here on your factor. Okay. Line up your coefficients. So you notice here x cubed, x squared, x number. So I'm not going to need any placeholders. Put the coefficients in front of these numbers. So 1, negative 3, negative 13, positive 15. Skip a line. Remember, above the line, you're adding and subtracting. Below the line, you're multiplying. Always bring the first term down. So I'm just bringing down that 1. Now from here, I'm saying 1 times 1, which is 1, above the line. So I'm adding these together. Negative 3 plus 1 gives me negative 2. Below the line, so I'm multiplying 1 times negative 2. It's kind of like you zigzag. And I'll give you negative 2. Above the line, add these together. Negative 15. Last term, 1 times negative 15. Give you negative 15. Add. Get a remainder this time of 0. So this is now a polynomial of 1 degree less. So it started out with x cubed, so now that means then this is x squared, x, and then number. So we can write this now as x squared minus 2x minus 15. And we have a remainder of 0. Since the remainder is equal to 0, that means that x minus 1 is a factor of our polynomial here. And we now know that if I were to take this polynomial, the x squared minus 2x minus 15, and multiply it times the x minus 1, I would get this right back, this original polynomial. I'd get that right back. But notice here, if we take it one step further, okay, and technically all that I'm asking you to do in this problem is just to find the quotient. And so this right here, x squared minus 2x minus 15, that's the final answer. But notice how that x squared minus 2x minus 15, that could be factored further. We've done it before. The only way to multiply to give you x squared, x times x. Most common way to multiply to give you 15, 5 times 3. Since you want a negative 2 in the center, you have to make your 5 negative and your 3 positive. You have x minus 1. What this is now going to allow us to do is to find all of the zeros of that polynomial, right? Because if we set all of these equal to 0 and solve for x, the first one's going to give me a 0 of positive 5, negative 3, positive 1. So these are our zeros. Okay, so that's where we're headed. Okay. All right, so flip it on over. Top of the next page, we pick up what's referred to as the remainder theorem. And the remainder theorem says that if you take a polynomial function f of x and divide it by x minus c, then the remainder is f of c. So essentially, you could have found the remainder by just taking the polynomial itself and evaluating it at c. Now remember, c will be the opposite of your factor. Okay. So here in example 6, I gave you this polynomial function, and they say I'm going to have us investigate the what the remainder is of this polynomial if we were to divide it by x plus 1 through long division, synthetic division, and then using the remainder theorem. Because I think if we just did the remainder theorem straight away, I think it would kind of look like magic and it wouldn't quite make sense. So I think if you see where it comes from in terms of regular long division and synthetic division, that then whenever you see it utilized for the remainder theorem, it all kind of ties together. So, plus I'm sure it won't hurt us to do another long division. If you want, it might be a good opportunity for you to pause the video and try that long division for yourself. Make sure that you're tracking with it. Notice here that it's all in descending order and you've got every term you need. So I'm just going to write this minus 6x cubed plus x squared minus 20. And now I'm going to go through my long division. Remember, this is imaginary 1. So 1 times what gives you 1x to the 4th? Well, you got 1x, you need 4, so this will be x cubed. X cubed times x to the 4th, x cubed times 1 plus x cubed. Draw your line, change your signs. The x to the 4ths cancel out. Have negative 7x cubed plus x squared. 1 times what gives you negative 7? So that would be negative 7x squared. Negative 7x squared times x, negative 7x cubed. Negative 7x squared times 1, so that would be a negative 7x squared. Draw your line, change your signs. 7x cubes cancel out. That'll leave me with 8x squared plus 24x. 1 times what gives you 8? Positive 8. You've got 1x, but you need 2, so another x up there. 8x times x. 8x squared, 8x times 1, positive 8x. Draw your line, change your signs. 8x squareds cancel out. 24 take away 8 will give you 16x. Bring down that last term, minus 20. 1 times what gives you 16? Positive 16. 16 times x, 16x. 16 times 1, positive 16. Draw your line, change your signs, add down. You have negative 36. That's our remainder. That's classic old school long division. Okay, that's the way we find our remainder, negative 36. Okay, let's now look again at another example of synthetic division. We're taking this polynomial and dividing it by x plus 1. So inside the box, remember, opposite of this factor here, what would the 0 be? The 0 would be negative 1, so that's what we put inside our box. Line up the coefficients. So I have 1, negative 6, 1, 24, negative 20. Skip a line. Remember, above the line you add or subtract, below you multiply. Bring down the first term. Negative 1 times 1, negative 1. Add together. That'll give you negative 7. Negative 1 times negative 7, positive 7. Add. Give you 8. Negative 1 times 8, give you negative 8. 24 minus 8, 16. Negative 1 times 16, negative 16. That last column is always the remainder. Add down, negative 36. So sure enough, we're going to get a remainder of negative 36 regardless of what we do. And remember, this is a polynomial of 1 degree less. So if we start out with x to the 4th, here's your x cubed, x squared, x, and number. And sure enough, that's the exact same answer that we have right up here when we did long division. Okay, so that's the correlation. So now, what I want us to do now is let's use the remainder theorem to find the remainder. And like I said, what the remainder theorem states is that to find the remainder, you could simply evaluate your polynomial at your 0. So Then remember, the 0 is what you put out here in your box. It's the opposite of the factor. So you're going to be finding, in this case, f of -1. Go to your function. Everywhere you see an x, you're plugging in -1. So I have -1 to the 4th minus 6 times -1 cubed plus -1 squared plus 24 times -1 minus 20. And then just work through that. So this is going to give me a +1. If I take a -1 and I cube it, I get -1 times -6, so that's going to be a +6. Negative squared, so that'll be a +1, minus 24, minus 20. And sure enough, if you add all of that together, you're going to land also at -36. So, and agreeably, that's a quicker way to get to the remainder, but I think now you have a better understanding of, what the remainder is and that sort of thing, okay? All right, so I encourage you to try example 7 on your own. We'll move on down then to the factor theorem below. The factor theorem states that, here it is, let f be a polynomial function, then these next two statements are true. If f evaluated at c equals 0, then x minus c is a factor. If x minus c is a factor, then f evaluated at that c is equal to 0. So basically it's going both ways, okay, and things that we've already talked about. So here in example 8, part A, it wants us to determine if x minus 1 and x plus 2 are factors of this function. So if they're factors, then the remainder, if they're factors, the remainder should equal 0. And the remainder theorem said, okay, well, you can plug in the opposite of your factor, which is the 0. So if x minus 1 is a factor, then f of +1 is a 0. Okay, f of +1 would equal 0. So what we're going to do is just to check to see if this happens. Check to see if this happens. So I will find f of 1 here. So f of 1 would equal 2 times 1 cubed minus 1 squared plus 2 times 1 minus 3. We'll just sort of work through it here. 1 cubed still 1, so 1 times 2, still 2. 1 squared is 1. Next term, 2 times 1 is 2. And you have minus 3. And then sure enough, if you add these four numbers together, you're going to land at 0. So what that means here then is that, yes, x minus 1 is a factor of f of x, and 1 is a 0 of f of x. Okay? So once and it goes both ways. If 1's a 0, then x minus 1 is a factor. Okay? All right, I'm going to let you try the next one. I think I've shown good work on the solution key for part B. We'll move on down then to the next fact. It says a polynomial function of degree n, where n is greater than or equal to 1, will have n number of zeros, or the multiplicity will add to n. Okay, so that will be a nice way for us to check ourselves as we move forward with our polynomial functions. I'm going to look at example 9 and 10 together on both so that you can see the different nuances between the two different problems. So here in example 9, the degree of this, they tell us to determine the degree of the polynomial, and then note how either the zeros or the multiplicity are going to add up to get that degree. So the degree of this polynomial, remember, is the highest degree, so you have 2, 1, 0. So the degree of this polynomial is 2. So that means I need to have 2 zeros, or the multiplicity has to add up to 2. So let's find our zeros. To find our zeros here, we would need to factor. The only way to multiply to give you x squared, x times x. Think about the most common way to multiply to give you 12. 4 times 3. I want a -1 here in the center, so I would need to make my 4 negative, 3 positive. And I could set both of those equal to 0. Now you're seeing, okay, I'm going to have a 0 at +4. And if I set this equal to 0, I'm going to have a 0 at -3. So, sure enough, my degree was 2. So that meant that we expect 2 zeros. And sure enough, we have 2 zeros. Those are our 2 zeros. We would be crossing the x-axis at 4 and -3. Okay? All right, let's scoot on over here to example 10. In example 10, you'll notice here in terms of having to find your degree, you'll need your leading terms. So you have negative x squared times x to the third power. So negative x squared times x to the third power. That's going to give you negative x to the fifth power. So that tells us here that we are degree 5. So what that means is I need to either find 5 zeros or my multiplicity has to add up to 5. Okay, so let's first find our zeros. Your first one, you have negative x squared equal to 0, and you have x minus 1 to the third power equal to 0. And we really don't have to worry about that third power. I just kind of wanted to have those exponents there. So this first one, if you solve for x, you're going to divide by the negative, so then you're going to have x squared equals 0, so you're going to have x equals 0. So you have a 0, so we'll kind of list this out. You have a 0 at 0, you're going to have the x-axis there, but its multiplicity on that 0 is exponent is 2. Okay, let's come over here to the next one. So if you take x minus 1 and equals 0, then, and again, I really don't need to worry about that 3, so I'm going to just erase it for now. I'm going to solve for x, so I'll just add 1 to both sides. So x equals positive 1. So now I have another 0 at positive 1. The exponent on that term, though, was a 3, so that means my multiplicity is 3. In this case, I have 2 zeros, but my multiplicity adds up to 5. Okay, so that's what this fact up here is telling you, that either you're going to have, depending on what your degree is, your zeros are going to either add up to that number or your multiplicity will add up to that number. Okay. All right, let's flip it on over. Next page. Your next theorem is in terms of complex zeros. And the first theorem says that your complex zeros and your radical zeros come in pairs. Okay, so the first one, if a plus bi is a 0, then a minus bi is a 0. The only sign that changes is the number in front of I. So here in example 11, if 6i is a 0, then we automatically know that negative 6i is a 0. For our next one, if 2 plus I is a 0, then that automatically means that 2 minus I is a 0. Imaginary zeros come in pairs. All right, your next one, your square root zeros. Here you have a plus b square root of 0 is a 0. If a plus b square root of c is a 0, then a minus b square root of c is also a 0. Again, the only sign that's changing is the piece in front of the square root. So it tells us here if the square root of 5 is a 0, then we automatically know that negative square root of 5 is a 0. On example 14, if negative 2 minus 3 square root of 7 is a 0, then negative 2 plus 3 square root of 7 is a 0. Imaginary and radical, your square root zeros come in pairs. But if you have a whole number, just because negative 1 is a 0 does not mean positive 1 is a 0. Okay, it's only these complex zeros like you see here. So in the example below, it says, given your polynomial function of degree 4, find the other zeros. So if it's degree 4, then that means we should be able to find 4 zeros, or multiplicity would add up to 4. But in this case, we would have to assume that we would have 4 zeros. So as you look through example 1 here, you notice how your first 0 is negative square root of 2. Because it's a square root, you know it comes in pairs, so you have to have positive square root of 2 is also a 0. Whole numbers and fractions, they can stand alone. Okay, so those now is your 1, 2, 3, 4 zeros. Let's look at the next example. You have I as a 0. I's come in pairs, so if you have positive I, then you have to have negative I. Okay, so there's a 0. Your next term is a square root. Negative 3 plus the square root of 3, so I have to have negative 3 minus the square root of 3 is a 0. Now I have 1, 2, 3, 4 zeros because I was degree 4. Okay. All right, so let's look at example 15. All right, so if we move down to example 15, they want us to write a polynomial of least degree with the given zeros. So the first thing you need to make sure is that they've given you all the zeros. So, you know, the first one they give you negative 1, so we know negative 1 does not come in pairs, but the next 0 is 1 plus 4i. So remember, imaginary zeros come in pairs, so this would be 1 minus 4i is also another 0. Now I need to turn these zeros into factors. So in order to do that, the way to do that is that if -1 is a 0, I'm just going to kind of burn a step here. This means x minus -1. And then the next term would be x minus 1 plus 4i. And the next one would be x minus 1 minus 4i. Because remember, whenever you pull out the zeros from the factors, you take the opposite. So if you're going to go backwards, then you're changing the signs. So if you can go straight away to, if you have -1 as a 0, to its factor being x plus 1, by all means do that, okay? Just be sure you distribute that negative through and change all the signs. So like for my next term, I would have x minus 1 minus 4i. And then for my next term, I'd have x minus 1 plus 4i. Okay? This is a hard problem. Okay? I'm just going to go ahead and lead with that. Okay? Now, from here, they want the polynomial, so they want us to multiply this out. Okay? What I would recommend that you do from here is let's take these last two parentheses here and let's multiply those two together. Now, we could do long multiplication here with x minus 1 minus 4i times x minus 1 plus 4i. But if you'll notice, inside both of these parentheses, they have that first term in common. So when I FOIL it, I'm actually going to treat this as a FOIL problem, because I'm going to treat this as a 2-term and another 2-term, that I have x minus 1 minus 4i. So I'm treating that x minus 1 as one term minus 4i. X minus 1 is the same another term plus 4i. So when I FOIL, when I do that first FOIL there, when I multiply x minus 1 times x minus 1, then I'm doing a FOIL within a FOIL. I know, it's like, why did I start with this problem, huh? I'm sorry. So when I FOIL here, x minus 1 times x minus 1, let me just come over here to the side. X minus 1 times x minus 1. I'm just FOILing here. So x times x, x squared. X times -1, so minus x. 1 times -1 times x, another minus x. And then last, -1 times -1, positive 1. Combine like terms, and I have x squared minus 2x plus 1. So I just did my first. Now outside, x minus 1 times 4i. And let's kind of piggyback off of some things that we were able to see in some previous sections. You notice how here, when you multiply your outside, you're going to have 4i times you have positive 4i times this x minus 1. So let me write this. I'm going to have positive 4i times this x minus 1. I'm just going to write it like this. And then when I do my inside, I'm going to have negative 4i times this x minus 1. And then my last, -4 times positive 4 will give me a -16. I times I squared. My point in here was writing that out was to show you that hopefully you see here your outside and your inside terms canceled out, because you've got positive 4i times that and negative 4i times that. So that completely goes away. Both of those terms are gone. So let's kind of clean this up. I have x plus 1. And I have left over here x squared minus 2x plus 1. And then back here at the back I have minus 16. And then remember, we know that I squared is equal to -1. So now I have x plus 1, I have x squared minus 2x, I have positive 1, and I have positive 16, so I really have positive 17 now. Back in with me. Now, this looks a lot better, that I now need to multiply x squared minus 2x plus 17 times x plus 1. We'll do that long multiplication. Go through and multiply 1 times everything. 1 times 17. 1 times -2x. 1 times x squared. Now go through and multiply x times everything. X times 17. X times -2x. And then x times x squared. Add down. X cubed minus x squared plus 15x plus 17. That's our final answer. And if we were to, kind of break this down and go backwards, we would find that this polynomial would have zeros at -1 and imaginary zeros at 1 plus or minus 4i. Okay. All right, so let's look over here. Let's do another one together. So the example over on the right, you have a 0 at 2i, so you know that comes in pairs, so you have to have negative 2i. You have negative square root of 3, so it has to also come in pairs, so we've got positive square root of 3. Turn these zeros into factors, so 2i is going to turn into x minus 2i. Let's put them together. So then the next one you have minus 2i, so that would be x. I'm going to burn a step here, so minus a negative 2i, just so you see it. Then take care of my square root of 3, so I have x minus a negative square root of 3 and x minus positive square root of 3. Next thing I would do is let's clean this up so that I'm looking at about not having these double signs. So I have x minus 2i, x plus 2i, right? Because two negatives side by side turn into a positive. X plus square root of 13, x minus the square root of 13. And now what I would recommend that we do is that we FOIL the first two together, get that cleaned up, FOIL the last two together, get those cleaned up, and then FOIL again, okay? So if we FOIL at the beginning, so x times x squared, outside plus 2ix, inside minus 2ix, last minus 4i squared. So that's the first parenthesis. Let's go ahead and take care of the back here. FOIL again, x times x, outside minus square root of 13x, inside positive square root of 13x, and then last, anytime you take a square root and multiply it times itself, get what's inside, but it's not going to be positive here, is it? A positive times a negative will give you a negative 13. Okay. Now from here, notice what happens in both of these parentheses. Your middle terms completely cancel out. You've got a positive and a negative 2ix. So I'm left with x squared minus 4. I squared we know is negative 1, so let's plug that in. In the second parentheses, those negative and positive square root of 13x's go away. That leaves me with x squared minus 13. Where did I get a 13 from? Those should be 3's. I'm sorry. It doesn't affect too much, but those should be 3's. I'm sorry. You were probably wondering, where did I get 13? Gracious. You would have minus the square root of 3 and positive the square root of 3. Those square root of 3's cancel out. So sorry about that. And then the last term, square root of 3 times the square root of 3 is just 3. Okay. So again, there's no 3 there. The 13 just all of a sudden just looked weird to me. So x squared minus 3. Glad I caught it. All right. So now from here, that first parenthesis can be cleaned up, and we'll turn that into x squared plus 4 times x squared minus 3. And just FOIL from here. Multiply your first. X squared times x squared. X to the 4th. Outside. So here's your first. Outside. Minus 3x squared. Inside. Plus 4x squared, last, minus 12. Combine like terms, so I have x to the 4th plus x squared minus 12. Final answer. And notice here it's degree 4, and sure enough we started out here at the beginning with 4 zeros. And if you were to work backwards now, you would find that you cross the x-axis at positive and negative square root of 3, and then you've got two other imaginary zeros at your plus or minus 2i. All right, we'll scoot on down then just below that. We're just working backwards here in example 17. They want us to write an equation of least degree polynomial with the following zeros and multiplicity. We're just going to leave it in factored form. We're not going to multiply it out like we did those previous two. So the first one, example 17, says that we have a 0 at 0. So 0 is the 0, and it has a multiplicity of 5. So to write 0 as its factor, that would be x minus 0, and that would be raised to the 5th power. And we'll come back and clean this up in a moment. Negative 2 is a 0, so we'll have x minus a negative 2. Has a multiplicity of 6, so that means it's going to be raised to the 6th power. And then our final 0 is 7, so that would be x minus 7, and has a multiplicity of 3. So the last thing I want to do here is just clean up. You know, x minus 0 is still x, so I can just rewrite this first term as x to the 5th. clean up my next parenthesis and make that x plus 2 to the 6th power. And the last parenthesis just will stay the same, x minus 7 to the 3rd power. And there you have it. That's your polynomial, okay? You know, hopefully you're starting to see the correlation here that when negative 2 is a 0, then its factor is x plus 2. When 7 is a 0, its factor is x minus 7. So they're going in backwards, okay? Or opposite of what they are. All right, let's move on down to example 18. In example 18, it says, given that negative 5 is a 0 of this polynomial function, they want us to find the other zeros. So if negative 5 is a 0, then that means if we were to divide this polynomial function by its factor, then we would have a remainder of 0. So let's divide, use synthetic division by using our 0 here, and get our polynomial down to something that would be, because it'll be 1 degree less after we use synthetic division, then that'll be something that we can factor, or maybe you just go straight away to solving, okay? So we're going to put negative 5 in our box and line up our coefficients, and I've got x cubed, x squared, x numbers, so I don't need any placeholders. So 1, 5, negative 2, negative 10. Bring down my 1. Remember, above the line you add or subtract, below the line you multiply. Negative 5 times 1, negative 5. Add, you got 0. Negative 5 times 0, 0. Add, you have negative 2. Negative 5 times negative 2, positive 10. We expected to have a remainder of 0, right? Because they told us that negative 5 was a 0, so we should have gotten a remainder of 0. This is 1 degree less, so remember this is x squared, x, and number. So now I have x squared minus 2. From here, set this equal to 0 and solve for x so that you can find your other remaining zeros, right? Because if this is degree 3, then I need to either find 3 zeros or some multiplicity has got to add up to 3. So let's solve for x here. I'd add 2 to both sides. X squared equals positive 2. Take the square root, so x equals plus or minus the square root of 2, right? Because I'm taking the square root of both sides. X equals plus or minus the square root of 2. So what this tells us then is that we have zeros. They told us at negative 5, and then we just found positive square root of 2 and negative square root of 2. Since those are your zeros, then you just kind of reiterate and just make sure you're seeing all the connections that we've been doing. If these are your zeros, then I can turn these into factors. So if negative 5 is a 0, then its factor is x plus 5. If positive square root of 2 is a 0, then its factor is x minus square root of 2. And then if negative square root of 2 is a 0, then its factor is x plus square root of 2. And so these are what are referred to as your linear factors. These are your linear factors. And just above that, of course, are your zeros. Okay? All right, let's flip it on over. Next page, at the top, we have what's referred to as the rational zero theorem. At the top, it just tells you, okay, well, here's your standard polynomial in descending order. And it tells us, for our rational zero theorem gives us what the possible zeros are that we could find in our calculator, okay? So the possible rational zeros are all possible combinations of plus or minus p over q. And let's go back and make sure I didn't say this. P divides the last term of your polynomial, and q divides the first term of your polynomial. So let's illustrate this, okay? But again, all of the possible rational zeros that you could potentially see in your calculator, remember zeros are where you cross the x-axis, are any combination of plus or minus p over q. So let's kind of work through this. Here in example 19, they want us to list all the possible rational zeros. So the first thing we need to talk about is, okay, well, p divides the last term. So the last term here is 6. I don't need to worry about the fact that that's a negative 6, okay? I just, because everything's going to be plus or minus. So p divides 6, and q divides the first term. So q divides 2. Now, I want to list all of the ways that I can multiply to get 6. So think about it. You have 1 times 6 and 2 times 3. Those are the only ways that you can multiply to get 6, okay? And the only ways to multiply to give you 2 are 1 times 2. Usually what I like to do is that I like to list these in order. So I have 1, 2, 3, and then 6. It helps me whenever I go to write now my P over Q possibilities. It is plus or minus P over Q, so it's plus or minus, and I'm just methodical about it. I do 1 divided by 1, so that's 1. 1 divided by 2, okay, so 1/2. Now I take 2 and divide it by my Q, so 2 divided by 1 is 2. 2 divided by 2 is 1, and so you already had 1, so you don't need to list it again. Now move to your 3. 3 divided by 1 is 3. 3 divided by 2, so 3/2. And then your next one, 6 divided by 1 is 6. 6 divided by 2 is 3. We've already listed it. So any combination of plus or minus any of these values here are where you could possibly cross the x-axis, okay? So now in part B, I say, well, now let's use our calculator to find all the zeros that appear. And I forgot to open up my calculator. Oh, calculator. You can go ahead and put the function here in your y equals in your calculator. I'd like to illustrate it for you at least one time. Into y equals, and put in our function here, which was 2x cubed, so 2x cubed plus 11x squared minus 7x minus 6, and then hit graph. Let me hit zoom 6 on my window so I can see it a little nicer. Okay, so I have a zoom 6 here. If I wanted to adjust my window so that I could see that peak up there, I certainly could, but it's really, really what I'm concerned about is where I'm crossing the x-axis, and I can see that I'm picking up 3 places here. So this is where you go through second trace, number 2 for your zeros, and again, it asks you for left bound and right bound. We've done this before, but like I said, I thought it would be good to probably revisit this. I'm going to focus here on this first one over here on the left. I'm using my left arrow key. Now notice how, okay, so now left bound in relationship to this point, this 0 over here far left bound would be below the x-axis, so I hit enter. Now it was asking for right bound, so I get my cursor above the x-axis and hit enter. I usually like to get close to my point, but this problem isn't going to let me get close, so I just go ahead and hit enter. So I can see I have a 0 at -6, so that's one that I'm going to write on in our notes in just a second. You notice over here it says -9 e to the -12. That means you have -9 with 12 zeros in front of it, so that's 0, okay? All right, you repeat that process. Second trace, number 2, to find the zeros, and now I'm just going to use my cursor, using my right arrow key. I'm going to find the middle 0. This time, right bound would be above the x-axis, so hit enter. Sorry, left bound would be above the x-axis. Right bound is below the x-axis. I'll just get myself down there below, hit enter. And then I'm going to guess closer up here to the x-axis. And I have -0.5, which we know is -1/2. And then I'll repeat that one more time. Second trace, number 2 for the zeros. Use my right arrow key. Left bound this time will be below the x-axis. So hit enter. Right bound's going to be above the x-axis. Anywhere up there will do. And then I just put my guess closer to the x-axis, and so I'm also crossing out 1. These were all examples of perfect zeros. So from our calculator, we were able to see that we had zeros at -6, -1/2, and +1. And notice how this was degree 3. We expected 3 zeros, and we got all 3 of our zeros from our calculator. And notice also that all of these values are in this list, okay? Because remember, all these values are plus or minus. Now it says write these zeros as factors in linear form. So if -6 is a 0, then its factor is x opposite +6, right? If -1/2 is a 0, then opposite would be x +1/2. And then lastly, if +1's a 0, then its factor will be x -1. One last thing here in terms of keeping this in a linear format, because this middle term here has a fraction as a 0, you've got 2 options. You can put a 2 out in front, to account for that 1/2. Okay, so we can do this. Or you can keep what we had there in blue to begin with, x plus 6, and take the denominator and move it up as a coefficient in front of that term itself, 2x plus 1. I can't remember which way my lab math prefers, so just be aware of that. But at least you see both ways, and so and they may take both. Okay, and so that would be your final answer. Again, if you have a fraction as one of your factors, then you either need to take that denominator and make a full whole number out in front, or personally, I just prefer to do like I did over here in red. Just take the denominator of that term and pull it up in front. Okay, personally, I prefer that form. Okay, but either way is fine. All right, so let's look down here at example 20. In example 20, they want us to list all the possible zeros. That's where we're going to do our P over Q. So remember that P divides the last term, so P divides 4. Q divides the first term, so Q divides 3. List all the factors of 4, so we have 1, 2, and 4. Right, 1 times 4 and 2 times 2. List all the ways to multiply to give you 3. 1 times 3. So then our P over Q possibilities are going to be plus or minus. We have 1 over 1, so that's going to be 1. 1 over 3. 2 over 1. 2 over 3, 4 over 1, 4 over 3. Those are all of your possibilities. You would go to your calculator now and find your calculator zeros. I'm not going to go through all those steps again. Take a minute, pause the video, go to your calculator, find all of your zeros. When you come back, you should find those calculator zeros to have been at -1, 3.41, 0.59, and 0.67. Okay, the middle two zeros here that I've listed, we need to find those as exact values. Okay, we need to find exact values. The first zero is -1. That's in your list. The last zero, hopefully you recognize that. That 0.67 is which fraction? And you only have 3 fractions here to choose from. So you could, if you don't know it, you could just say 1 divided by 3, 2 divided by 3, and 4 divided by 3. But 0.67 happens to be 2/3. So what's going to happen is we're going to use synthetic division now with the existing zeros that we know to get our polynomial reduced to something that we can find out what the exact form is of those two middle polynomials. So to find my zeros now, I'm going to put -1 and line up my coefficients. So I have 3, -11. Notice how I'm missing the x squared, so I'm going to put in 0, 10, -4. Bring down to that 3, so then that's going to give me -3. That'll give me -14, +14, -1 times 14. That'll give me -4. Remainder of 0. That's what we expected. Now remember, this is a degree less, so this is now x cubed, x squared, x number. So let's go again with our next 0, which was 2/3. And don't let the fraction here scare you off. This will actually work out nicely. So you have 3, -14, +14, and -4. Bring down that 3. 2/3 times 3, well, those 3's cancel out. Just leaves you with 2. -14 plus 2 will give you -12. And if you're not good with the fractions, just put in your calculator. 2 divided by 3 times -12. That should land you at -8. Because essentially you're doing 12 divided by 3 is 4. 4 times 2 is 8. And you had a negative. 14 minus 8 is 6. In my head, I'm doing 6 divided by 3 is 2. 2 times 2 is 4. But again, just use your calculator if you need to. You're doing 2/3 times these bottom numbers. Now you are a polynomial degree less. So you started here x cubed, so now you're at x squared, x, and number. So we'll come over here, and we have 3x squared minus 12x plus 6 equals 0. I'm going to go through now, and you notice that all three of these terms have a 3 in common, so let's factor out that 3. X squared minus 4x plus 2 equals 0. And fortunately from here we usually try to factor, but this is not going to factor, so we're going to have to use the quadratic formula. So remember there's your A, your B, and your C, so it's opposite B. So 4 plus or minus square root B squared, so negative 4 squared. I'll write it for us, negative 4 squared, minus 4 times A times C, all over 2A. So then that cleans up and gives us 4 plus or minus the square root, negative 4 squared, of course, is 16. 4 times 1 times 2 will give us minus 8, all over 2. Starting to look better now. 4 plus or minus the square root of 8 divided by 2. We need to reduce the square root of 8, so hopefully you agree that we could rewrite 8 as 4 times 2. We know the square root of 4, so I have 4 plus or minus 2 square root of 2 all over 2. Now notice here outside of the square root, 2, 2, and 4 all have a 2 in common. Divide them all by 2 to get you a final answer of 2 plus or minus the square root of 2. You just picked up your last two zeros. So if you were to put in your calculator 2 plus the square root of 2, you're going to get that 3.41. And if you do 2 minus the square root of 2, you're going to get your 0.59. Okay? So now you have all of your zeros. So we know that our zeros were negative 1, 2/3, 2 plus the square root of 2, and 2 minus the square root of 2. Lastly, here in part D, they want us to write these as factors. So that first term, so if you have negative 1 as a 0, then the factor turns into x plus 1. If 2/3 is a 0, then it's x minus 2/3. Now note that you're changing your signs, so when you get back here to these last two zeros, you've got to change the signs on both terms. So my next 0 will be x minus 2 minus square root of 2, and then x minus 2 plus square root of 2. Just like I talked about before, you need to do one of two things. If you have this, since you have a factor here with a fraction, you either need to move that denominator up in front of the factor, or you can put it in front here. So I'll write it that we could just bring a 3 out here in front and leave it in that form. Or we can say we can leave x plus 1, turn this term into 3x minus 2, and keep everything else the same. Okay. All right, so let me look at if there's anything else going on, any of these other problems. I think that the next one will follow, number 21 will follow exactly what we just did here in this one, so I'm going to skip that one, let you follow the solution key for that one. In example 22, I think this will be a good one to show. There's a little bit something different going on in this one. All right, so in part A, they want us to list the possible zeros. So remember, p divides the last term, so p divides 50. Oh, shoot, the page moved on me. P divides the last term, so p divides 48. And q divides the first term, so q divides 1. And when you come up here to listen to all the factors of 48, think about ways to multiply to give you 48. Then 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 won't, 6 won't, 6 will, 6 times 8, 7 won't, and then the next number is 8, and once you start to repeat yourself, you know you found all the factors. So my p over q possibilities then are plus or minus, and the only factors of 1 down here are 1, so my p over q possibilities then are plus or minus basically all of these numbers. I'm just going to list them in order, because you'd have 1 over, you know, the only factor down here of q of 1 is 1, so you'd be taking all these numbers and dividing by 1. So you have 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Okay. Part B wants you to find your calculator zeros. So whenever you go to graph this in your calculator, the only two zeros you're going to be able to find are 2 and negative 3. I'm going to draw a rough sketch of what you see in your calculator, and it might be good for you to pause the video, but what you see in your calculator is it's crossing here at this, here's -3, and here's our +2. Graph looks something like this. So notice how it's crossing there at the -3, so we know at that point that we've got an odd multiplicity, but at 2, because you're bouncing, you have an even multiplicity. What that means then, whenever, and we know that we're supposed to be finding either 5 zeros or multiplicity that adds up to 5, then what that means in terms of our synthetic division when we do our next step is that we can put 2 into synthetic division more than one time, okay? So let's start with the 2. Even multiplicity. Okay, it either has to happen twice or 4 times. So we put in our 2 and line up our coefficients. It is all in descending order, so 1, -1, -4, 8, -32, 48. Bring that first term down, which is 1. 2 times 1 is 2. 2 minus 1, 1. 2 times 1 is 2. Add, be -2. 2 times -2, -4. 8 minus 4, 2 times 4, 8. -32 plus 8 will give you -24. 2 times -24, -48. You should always get a remainder. If you found it to be a 0 in your calculator, you better get a remainder of 0. Now this is a polynomial of 1 less degree, so you start with x to the 4th now. Let's do 2 again. We know it has an even multiplicity, so let's do 2 again with now these coefficients. So 1, 1, -2, 4, -24. Bring down my 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. 6 minus 2 is 4. 2 times 4 is 8. 8 plus 4 is 12. 2 times 12 is 24. Add down. Remainder of 0. Now you are sitting at a polynomial 1 degree less than that. Now you're at x cubed. From here, we had one more 0. We had a 0 at -3. So let's do synthetic division one more time. So once we get it down to something that's squared, we'll be able to factor or solve more easily using quadratic formula. So use -3 with these new reduced coefficients. So 1, 3, 4, and 12. Bring down that 1. Remember, above the line you're adding and subtracting, below the line you multiply. -3 times 1, -3. Add those, you get 0. -3 times 0. Add there, we get 4. -3 times 4. Add there, we get 0. That's nice. Because now, this is now 1 degree less here, so now you have x squared, x, and number. So now I can set x squared plus 4 equal to 0 and solve for x. So subtract 4 from both sides. X squared equals -4. Take the square root of both sides. We know square root of regular 4 is 2. Because it's -4, it will be 2i. And anytime you take the square root of something, it's plus or minus. So now you have all of your zeros. You have a 0 at +2. And I'm just going to put here in parentheses, it has a multiplicity of 2. You had a 0 at -3. And you have a 0 at +2i and -2i. And we said that our multiplicity or zeros had to add up to 5 because we started out here with a polynomial of degree 5. And so sure enough here, you have 1, 2, 3, 4, 5, because the multiplicity here would count twice. Okay, so those are all 5 of your zeros. All right, I know this was a long section. There's a lot going on here, but hopefully this helps. All right, thanks a lot. Let me know if you need anything.